Hello friends, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with spectroscopy, particularly ultraviolet visible spectra. This is lecture number 38. In this lecture I will explain you numericals, particularly of Diene system, and it is very important to explain you about cross conjugation. So what is cross conjugation? Let us see this example. Okay, here we can see this is a system of two alternate double bonds. One is in the ring, one is outside the ring. So this is one of the system. Okay, and here when one double bond is outside the ring, it is considered as acyclic Diene system. Okay, so particularly it is acyclic Diene system and or open chain Diene system. So we can consider this as acyclic or open chain Diene system. And you all know that for open chain Diene system, we are taking 214 nanometer for this. Okay, sorry, 217 nanometer. So base value of this will be 217 nanometer. This will be given to you. You don't have to remember this. Okay, so 217 nanometer for acyclic Diene system. Now we'll have to see which one is there any extended double bonds or not. Okay, so we'll go with one of this system over here. So we'll go in this direction. Now single bond, double bond, single bond, double bond, single bond, double bond. So this is the extension of the system. Okay, so in this case we'll have to see extra conjugated double bond. So how many extra conjugated double bonds? Which will be in green. And for each double bond we'll have to add 30. So 1, 2 and 3. There are 3 extra conjugated double bond. For each one we will add 30. So total 90 nanometer is added in base value. Okay. Now we'll go ahead with exocyclic double bond. So if there is any exocyclic double bond, this is the ring and these are two double bonds in the system, but this double bond is having both carbon in the same ring. So this is not an exocyclic, it is endocyclic double bond. But here this carbon is in the ring while this carbon is outside the ring. Therefore this will become exocyclic double bond. There is no other ring over here. So there is one exocyclic double bond. For each one we will take 5 nanometer. So we'll have to add 5 nanometer for this one. Okay. Now we will go ahead with ring residues and other substitutions. So the first is ring residue, that is alkyl groups. So let us check from the first double bond of the system over here. This carbon is attached to this double bond. So this is one ring residue. Then we'll go ahead with this double bond. This is one ring residue. From here we have this ring residue. Now this is the system and this is also one of the substitution, not ring residue but substitution, OR. Next is the last one. This is the ring residue. So how many ring residue? 1, 2, 3 and 4. So 4 ring residues. For each one we will take 5 nanometers. So 20 nanometer is added for that. Now there is one substitution of OCH3 group, that is OR. And for OR we are adding 6 nanometer for one. So there is one OCH3 group and we are adding 6 nanometer for this. So we'll add 6 nanometer for this and this will be your lambda maxima. Okay, so if you make a total of this, it will be lambda maxima. Now Why is it called cross conjugation? Let us take this. I have written this example once again over here, and here you can see this is a system. So our basic system remain the same. Okay. We earlier in this case we have extended the system on the right hand side, but now we have to extend this system on the left hand side also, because there are alternate pi bonds in the system extension, and therefore we will consider this one as extended system. Okay, now this is totally different from this one. So, but in both the cases you can see this basic system of Diene remain the same, and that is why it is called cross conjugation. Cross conjugation means the one system, the basic system remain the same. So here also we have acyclic Diene system, which is the same one, and for that one we will add 217 nanometer for this one. Okay, now we will see exocyclic double bonds. Earlier also we have seen that here this bond is a double bond which is exocyclic, because one carbon is in the ring, another is outside the ring, so there is one exocyclic double bond. 5 nanometer for this one, so we will add 5 nanometer. Sorry, we have to refer also extra conjugated double bond. These are the part of the system but extended system, and in green patch you will see two extra conjugated double bonds. So for each one we will add 30. So 60 nanometer for extra conjugated double bond. Now substitution. First of all we will see ring residue. So here this is the double bond and this is alkyl group attached to this. So one ring residue attached to this carbon. Next this one. Here also we'll see this carbon is attached to this one. So this is the second ring residue. Next is this one, which is carbon group attached to this one. So we'll consider this as ring residue. Next goes here. This is ring residue, and then here also ring residue. This is substitution. So 1, 2, 3, 4 and 5 ring residues. For each one we will add 5. So there are 25 nanometer for ring residues. And next is substitution, that is NCH3 twice group. That is NR2 group. And for NR2 group we are adding 60 nanometer for one group. So this way you will have to add this one. Now you make a total of this one. Lambda maxima. Okay, so here we have two systems. The first one we consider as a system where we are extending this double bond on the right hand side, and we have to find out lambda maxima for this one. The second system is this one, which is B system. For this also we'll have to find out lambda maxima, and then we make a total of this one. Whichever lambda maxima is higher will be the total lambda maxima of this system. So in cross conjugation we'll have to consider lambda maxima for two different systems A and B, and whichever having the higher value we'll consider that one. Okay, so this way we have to see cross conjugation. So cross conjugation is basically two different examples but sharing the same basic system. Okay, so that is about the cross conjugation, in which the basic system will be common for both the sides. Okay, the next example is this one. Sorry, let me see, 5 number, now 6 number. So This is 5-member ring. Again, 5-member ring. And this is the case. Now we'll have to see whether is there any cross conjugation or not. Okay. Here you find that the considering this double bond and this left side double bond, we'll have one system, one double bond here, one double bond here, we have another system. No, there is no cross conjugation. Why? Because these two are also forming a basic system. In the same case over here, there is no cross conjugation. So remember that there is no cross conjugation in this case. So no cross conjugation. And therefore we'll have to consider the basic system. So here we start from here. Both double bonds are in one system and in one ring, and they are cis to each other, so we will consider these as homoannular diene system. Okay, so our basic system is homoannular diene system. And for that we are adding 253 nanometer. Next is extension of cross double bond and system. So we can extend this way. Even this will go up to this one and here also. So now we have to find out extra conjugated double bonds. And for each double bond we are putting 30. So there are 1, 2 and 3 extra conjugated double bond in green system. And that is why we will add 90 nanometer for extra conjugated double bonds. Okay, next is exocyclic double bond. So here we'll consider each one of the system. So here there is these two bonds are in the ring endocyclic, so these two are not exocyclic, but let us take this one. One carbon is a part of the ring, but this carbon is not part of the ring, so this will be exocyclic double bond for the ring A. And now there is no other exocyclic, so only one exocyclic double bond, so we will add 5 nanometer for this one. Okay, next is ring substitution, ring residue or substitution. In this case ring residues. So here we start from here. We can't consider this as ring residue because this carbon is a part of a system. So we go ahead with this one. Now all carbons are part of system. Yes, this one. This is one ring residue for this carbon. Now next one is going here, and then this one. Again, this carbon is considered ring residue for this double bond. So total 2 ring residues. So we will add 10 nanometer for this one. And now we make a total of this, that will be lambda maxima for this compound. Remember, there is no cross conjugation in this case. Next one, similar to this one. This one. Well, it looks similar to this one, the first one. Okay, so